What is pressure? Let us discuss the explanation with examples, the definition of pressure. A person makes deeper marks while walking on a soft ground in a very narrow and sharp heel shoes than when walking in an ordinary shoes with flat heels. Do you know why? The reason is sharp heel shoes exerts a larger pressure in that small area compared to a flat shoes. Also, it is easier to push a sharp pin through a cardboard than it is to push a blunt one through the same material using the same force. Pressure is defined as force acting per unit area. The unit of pressure is given by pascals. So 1 Newton per meter square is equal to 1 pascals. Let us see a numerical on pressure. A solid exerts a force of 400 newtons. Calculate the pressure exerted by the solid on a surface if the area of contact is 200 centimeter square. Solutions: force is equal to 400 newtons, area is 200 centimeters squared. Since it is in centimeters squared, we have to convert into meters squared. That is the reason why I have divided 200 by 100 into 100. So pressure is given by force by area. So 400 by 0.02 meters squared, which gives the pressure is 20,000 pascals. Application of pressure. The edge of a sharp knife has a very small area of contact. This produces a very large pressure with a small applied force. Hence, a sharp knife, scissors, etc. cuts easily than a blunt one. High heel shoes sink deeper in a soft ground in comparison with a flat shoes. This is because in high heel shoes, weight is spread over a small area in comparison to flat ones. This results in a high pressure in a high heel shoes. Broad handles in bags and suitcases are provided for the comfort. What is the reason? Broad handles have larger area and it distributes the pressure. So the pressure exerted on hands and shoulders would be small while carrying the bags and the suitcase. Pressure in liquid. Activity 5 in your textbook. Show the variation of pressure in liquid. In a cylindrical container, the cylindrical container can be a plastic bottle, a mineral bottle, water bottle. Drill some holes along the side at different heights from the base. Close the holes with adhesive tape. Pour water into the container and open all the holes at the same time. Water flowing out from the hole at the top hits the ground at the least distance. You can see point C, the water hits the least distance compared to point B and point A. So here we can see that A, the lower hole A throws water the farthest, followed by B and lastly C. What is the conclusion, students? Pressure of water at A is greater than pressure at B and pressure at B is bigger than C. So we can tell pressure increases with depth. Activity 6 in your textbook also is take a cylindrical container, drill some holes all around the container at the same distance from the bottom. Same distance. Close the holes with adhesive tape. Now fill the container with water and pull out the adhesive tape. Water coming out of all the holes falls at the same distance from the container. This shows that a liquid exerts equal pressure at the same depth. Measurement of liquid pressure. Liquid pressure can be measured using a simple device which is shown here called as a manometer. It consists of a U-shaped transparent glass tube which is partially filled with water. One end of the U-tube is connected to a rubber tube, what you can see, the rubber tube, whose free end is fitted with a funnel. This is a funnel. At the open end of the funnel, a stretched rubber film is attached. A stretched rubber film is attached. So when you fill the cylindrical jar here with water and you want to measure the pressure, the liquid pressure, the following things you will observe. If you immerse the funnel into a bucket or a cylindrical jar of water, you will see the difference in the water level in the U-tube that you can see here, the difference in the water level. The deeper you immerse, the greater will be the difference in the water level. This means that liquid pressure increases with the depth. Implication of liquid pressure. The pressure exerted by water in the ocean increases with depth. So, the very deep down the pressure is enough to crush the human body. That is why deep sea divers wear special suits which can withstand high pressure and prevent their body to crush. The hull of the submarine specially strengthened. This is the hull of the submarine. It is specially strengthened to prevent it from collapsing from high pressure of the outside water while submerged. The pressure of the water increases as the depth of the water increases. The wall of a dam is much thicker at the bottom than at the top because it must withstand increased pressure in the depths of the water. Atmospheric pressure. There is an envelope of air that surrounds the earth. We call it as atmosphere, and wherever we go we see there is air around us. The atmosphere is bound to the earth by the gravitational attraction of the earth. So why you have got atmosphere in earth is because of gravitational force, you should tell. This atmosphere of air around us produces pressure at ground level or other levels due to the weight of the air above that level. So as you see here, at the ground level, the atmosphere pressure is the highest. As we go higher, the atmospheric pressure reduces. Simple demonstration of air pressure. Activity 7. Take a tin can and fill half it with water. Heat the tin can until the water starts boiling. Allow the water to boil for some time until the steam pushes out the air from the can. Close the lid, stop heating further, and pour cold water on the tin. What will you observe? You will observe that the tin can get crushed. Conclusion: the rising steam dries out the air from the tin can when the lid is closed and cold water is poured on it. The steam inside the tin can condense into water. As a result, a partial vacuum is created inside the can. The atmospheric pressure acting on the surface of the can from outside is much greater than the pressure acting inside the can. This huge pressure will crush the can, as you can see in this diagram. Implication of atmospheric pressure. Space suits are specially designed to protect astronauts from the low temperature and low pressure in space and to provide oxygen to breathe. It provides an atmosphere similar to Earth's, including oxygen and nitrogen. In space, as there is no air, we all know that. The air pressure is so low that it does not balance the pressure inside human body. Thus, wearing a spacesuit allows an astronaut to survive and work in space. In space, as there is no air, you can see here, the air pressure is so low that it does not balance the pressure inside the human body. Thus, wearing a spacesuit allows the astronaut to work, survive and work in space. This is a diagram of a simple barometer. A simple barometer was constructed by Torricelli, who was a student of Galileo Galilei. It is also called as a Torricelli barometer. It consists of a narrow, thick glass tube, as you can see in this diagram, about 1 meter long and sealed at one end. You can see at the top side it is sealed. The basic principle of a barometer is to use atmospheric pressure to balance vertical column. You can see the tube is placed vertically. So the basic principle of a barometer is to use atmospheric pressure to balance vertical column of mercury sealed at the top. Initially, the tube is completely filled with mercury and is carefully inverted into the trough containing mercury without allowing any air to enter. The mercury level in the tube drops a little. You can see, drops a little and remains steady at a particular height. It does not fall further because the atmospheric pressure balances the mercury column in the tube at that level. The portion above the mercury column is vacuum, as there was no air inside. As there's no air inside, here it is vacuum. The height of the mercury in the tube indicates the atmospheric pressure at that point of time. So here you can see the atmospheric pressure is 760 millimeter. At sea level, the height of the mercury in the barometer is 76 centimeter. So this diagram shows at sea level. This is also known as 1 atmosphere. Atmosphere, denoted by ATM, is the commonly used unit to represent atmospheric pressure.